Hi everyone, welcome back to our AP Calculus series, and today we're going to go over first derivative test and which will tell us a critical point, and the second derivative test, which tells us the concavity of a function. Alright, so as we all know, if I have a function that is f of x, then the derivative of that would be the slope of the function. And if slope, in the other words, is greater than 0, which means it's a positive number, then the function is increasing. And if the derivative is smaller than 0, the function is decreasing. And thus a critical point is where f prime x equals to 0. So for example, if I have a graph that looks like this would be the critical point, because as here the slope of the function is 0. And one property of the critical point is that it's very likely to be the maximum or minimum, because for example, in this graph, you can see that when the slope is 0, which means it's a critical point, this point is the maximum. And if we reflect it across the x-axis, you would see that the slope is still 0, but it's still one of the critical points, and it's the minimum of the graph. Alright, so as you can see in this graph, before the critical point, any number before the critical point, the slope is increasing, which means f prime x is greater than 0, and all the point after the maximum, which is a critical point, has a slope smaller than y, which means if the slope changes from positive to negative, the critical point would be a max. And in this case, if it changes from negative to positive, we would get a minimum. Alright, let's try a few examples. So if I have a function, let's say it's 4x squared plus 2x plus 1. So I first need to find the derivative. So it's f prime x equals to 8x plus 2. And to find the critical point, I need to set f of x, the derivative of f of x to 0. And I will get x equals to negative 1 over 4. And the next step is to see if like whether the function is increasing or decreasing. So if it's greater than negative 1 over 4, let's just say 0. If I plug in 0 into f of x, so derivative of f of x, I will get a positive number. And if I plug in a number that is smaller than negative 1 over 4, I will get a negative number. And from previous page, we know that if the derivative changes from negative to positive, I would get a minimum. Therefore, for this function, it's this function. So for this function, the minimum is at x equals to negative 1 over 4. So that's basically it for a critical point and first derivative test. And for the second derivative test, we use it to find the concavity of a function and the point of inflection. So the point of inflection is where the concavity of a function change. So if this is my function, then here is a point of inflection, because this part, the part before the point of inflection, concave up, and the part after the point of inflection, concave down. So and therefore this point is the point of inflection. So how do we find the point of inflection? So we first take the second derivative of a function and set it to 0. And then if the second derivative of the function is greater than 0, then that means it concaves up. And if it's smaller than 0, then it concaves down. Let's try example. So if I have a function called f of x equals to 3x cubed minus 2x squared minus 3. So I first need to take the first derivative. So the first derivative would be 3 times 3, which is 9, x squared minus 4x. And the second derivative would be the derivative of first derivative, and it equals 18x minus 4. And I will set this to 0, and I get x equals to 4 over 18. Then I'll do a sign chart. So if x is greater than 4 over 18, I would get a positive number. Otherwise, I would get a negative number. So the point of inflection is at x equals to 4 over 18, and if x is smaller than 4 over 18, then it's concave down. If x is greater than 4 over 18, then it's concave up. Alright, so if we combine the first derivative test and the second derivative test, we can sketch a function easily. So let's do an example. So if I have a function f of x equals x squared plus 2x plus 1, and I want to graph this function, I would first use the first derivative test to know like where is the function increasing and where is the function decreasing. So the first derivative of this function would be 2x plus 2, and I need to set it to 0 to find the critical point, and I will get x equals to -1 as a critical point. And the next thing is the sign chart. So if x equals to -1, then when the x is greater than -1, I would get a number that is smaller than 0. If x is smaller than -1, oh no, sorry, actually when x is greater than -1, I would get a positive number. And when x is smaller than -1, I will get a negative number. Therefore, x equals to -1 is the minimum of the graph. And then I will do the second derivative test to get the point of inflection and the concavity of the function. So the second derivative test would just be 2. So because 2 is greater than 0, therefore the function always concave up. Therefore, the graph would look something like this. So I have my minimum at x equals to -1, And if I plug in -1 into the initial function f of x, I would get 1 minus 2 plus 1 equals to 0. Therefore, I know that the vertex of the function is as -1, comma 0. And because it's concave up, it's likely to look like this.